Hi everyone. This is Lin's KNIME challenge, and this challenge is to use KNIME to gather information of a set of pictures of long city and then make some predictions. I made two predictions. One is related to the contract attribute of a long picture, and another is to predict the age of the long owner using the information of the long picture. And this is my first time to process to analyze data in picture format, so this is really a big challenge. And the images I used is from this website, and I because the format of the data, the picture is really special, so I can't have much information through these pictures at the beginning. The only information, but fortunately, I can extract some information through the file name. Let's say example. The data I used here is in TF images folder, and you can see in their names there's age, there's ID of the picture and the age of the long owner, and then the contrast of the long, some of them are 1 and some of them are 0. So this can be used as a target in the decision tree prediction. Yes, and the and when we open the picture, we can see the long city here, different long city, and this is all I have at the beginning to do my challenge. And I did these steps. First, load images in my computer into KNIME, and then extract the age and the contract information from the file name of each image, and then gather the data of image features as much as possible using some nodes in KNIME, because the information we already have is really not too much. So next, as we learned at the class last week, in order to avoid the overfitting, we need to make partition of the original data sets into training set and the validation set, and then is a operation of build prediction model and do prediction. Okay, let's turn to the KNIME page, and here, as I said before, the first step load image, and the second step extract information from the file name. These two steps both need some manipulation of the file names. So at first I use a list files node, and using this node, by configuring it, we choose our file path, and then apply it. We can see the information of our file, of the picture's location, and URL is here. And then using the string manipulation, we use this function substr and use a certain sentences to make sure we extract the name string out. So after this, we can see in the appended table, we can see one new column is added here, the image ID. And next step, we need to split all of this, split this image ID to chunks and choose the information we need. So using this cell splitter, we can see that we select the column we want to split and use the underscore to separate it, and after apply it, we can see in the table here the image ID column is separated in to seven individual columns, and then the next step we need to do is to select what we need and then remove what we don't need. So but to better recognize it, we can first rename some column. Like here, I changed the name of the area 3 to age and the area 5 to contrast. And then when I do the next step, column filter, I can easily recognize the column I need here, the age and the contrast. So here we can like add something we want, and remove something we don't want. So all of these steps are the prerequisite of loading the image in KNIME, and using a certain node, the image reader. Here we use the column location to give information of the file path to KNIME, and then after using this, we can see there is a new column called image here. Here the picture is all dark, but it doesn't matter. It's maybe because of my computer, but it doesn't matter. The KNIME can still find the features of the picture like we see in the Photoshop here. So this doesn't matter. And then is the third step I mentioned before, is using the feature calculator to gather image data Yeah, this node is very powerful. This can automatically this node, it can automatically recognize images and calculate up to 18 statistic features. You can see here is including the sum, the maximum, the mean, and the some inverses and so on. Excuse me. But when we see the computed features here, we can see that using the columns here, we can see that a lot of the features are not useful, like the sum of logs and the moment variable mean. This is all in 0 and this is all in infinite, so it don't make sense, and including the last two features. So next we better to do the column filter again and remove those features that are not useful. till now, the data preparation for predicting is finished, and then to do the prediction, the first step is to partitioning it into two sets, the training set and the testing set. I used the segmentation as 70% training and 30% testing. After this, we can see the first partition. There's 17, and then I said before I did two prediction. The prediction one is to predict the contrast using decision tree. We can see in this area, this choosing area, and using the node decision tree learner. In the configuration, we so the cost column is contrast, what we need to predict, and then add the proper information here. Then apply it. After it, using the decision, we can get a decision tree model, but it's not very visualized. It's not visualized well, so it's maybe confusing for some people. So I use the decision tree to image node to visualize it, and we can see the result here is a very clear image, and we also can view it here. Here at this panel, we can expand. Then we can expand selected branch or class selected branch, and this is very helpful and clear for us to see the different branches. And if you want to save it, you can export it as PNG here. After we have the decision tree model, we can use it to predict. So we use the decision tree predictor here, and we can see that there is a new column called prediction contrast here, but it's very hard for us to compare this column to the former contrast column. So I can do the column filter again. You can see in this table we can contract the contrast and the prediction contrast. We can see but still we could not have the accuracy. So I use the JavaScript ROC curve here. The function of this, to find the function of this, we can use a panel node description and to see what can this node do. And after this, we can see there is an image here. You can see the ROC curve, and then the prediction accuracy is almost 70%, which is acceptable for us. And the score node is to get the confusion matrix here. You can see I can see the result of the prediction here. Yeah, and then then we can go to the another prediction. It predicts the age of the long owner using linear regression. Before doing this, I do the same column filter here because the linear regression node here remind me, give me a notification that if I don't remove the contrast here, I can't use a node, so I have to do that. But I think contrast is very informative in predicting age, because let's imagine that the age of a person whose long contrast is 1, maybe older than other, may looks like older than other healthy people. So but I could not fix this problem, so this is where I need to learn more in the future. But I have to say the KNIME is really powerful and friendly. You can find a lot of functions from other data analysis softwares like Weka and R, and even using Python. So here I choose linear regression here, and after using that we get a training model here, linear regression and a linear regression equation. Yes, and using the equation we can use a predictor to do prediction. And again, after using that, we got a new prediction age column, but it's hard for us to compare, so I do another column filter. We can predict it. As we can see here, the age is a large part of the the testing data. The prediction is accurate. The distance between the real age and prediction age is less than 5. I think it's acceptable. But using this, we cannot. It's not very visualization friendly. So I use the line plot here. And with the line plot, we can see the red one is the real age, and the blue one is prediction age. To observe it more more easily, we can change using these functions to change the size of the dots, and then we can see better. So we can see that this is not very satisfaction, because I didn't find a better visualization node, so this is where I need to do later. And that's all my KNIME challenge. Thank you, everyone.